What I want to talk to you about in this video is how we can use our understanding of perfect square trinomials to help us when we can't just factor and get the answer to an equation. So let's look at these examples right here. These are trinomials because there are, as you can see, 1, 2, 3 terms. And they're perfect squares because if I factor them, I get here, I'm looking for how do I multiply to 3 and add to 6. So that is 3 and 3. So another way that I could write that would be x plus 3 quantity squared. In another example here that I could say it's the same thing. I'm thinking about how to add to 10, multiply to 25. So x plus 5 times x plus 5 or x plus 5 quantity squared. Again, these are all perfect square trinomials because if we turn them into area models, we would see that we have x and 5 and x and 5 for the dimensions to make a square, and it is a trinomial because there are 3 terms. What you can see in this slide is that if I'm going to take one of the examples from the previous to be able to just show you what this looks like on a graph. So when you have a perfect square trinomial, you can look at it here and notice that when you factor it, you can figure out when you're looking for your for your x-intercepts when y is equal to 0, that here x is equal to -3, and here x is also equal to -3. So that means you're sitting here at -3, and that's your only x-intercept. So that means, and because it's a 1 in the front here, that I know I go over 1 and up 1, or over 2 and up 1, 2, 3, 4, like this, and then I have my nice symmetry over here also. So the cool thing about perfect square trinomials, one of the many cool things about them, is that they also sit right on the x-axis, which is really nice. What I want to do in these situations is ask you to think about how to take these problems and turn them into perfect square trinomials. What could I add to them? They're all binomials right now, as you can see. But what could I do to create perfect square trinomials out of each? So I'm just going to see if I can scoot this down for just a second. So if I here, just remind you, you had x squared plus 6x plus 9, and that was x plus 3 quantity squared, or x squared plus 10x plus 25, and that was x plus 5 quantity squared. That one of the cool things about this is that this number here is half of my b, and when I square it, I get my c. So again, this doubled gives me the b, the c squared gives me the 9. So what I'm going to try to do now is I'm going to just take this part here and ask you to think about how to use these ideas. I'm just going to erase one of the examples. Here we go. No, I'm not. I'm just going to, we'll just walk through it. So what would I have to do so that when I think about it, there's going to be some number that's going to add to 8. Well, what do I know? It's going to have to be half of that. So it's going to be 4 and 4. So that means that I'd have to, when I FOIL, my last times my last would get me to 16. And let's check it out and see if that's the same relationship. My x plus 4, we're saying this is x plus 4, quantity squared. Is this half of that? Yep. Is this squared to get my c term? Definitely. So let's try another one like that here. So x squared plus 14, x plus something. So I'm going to say, how can I add to 14? To make this be a perfect square trinomial, I need a 7 and a 7. Because the 7 and the 7 gives us 14, and so I would have had to have added 49 to get there. Because that's x plus 7 quantity squared. Okay, so this should be the moment when you ask, why would you bother doing this? Seems cool, maybe, but why would you bother doing the work? So if on this problem here, I could subtract 3 from both sides and see if I could solve for what x is. But I can't. I mean, I'll subtract 3 and show you that's not going to get us anywhere. So I get x squared plus 14x minus 3 equals 0. I have to think about ways that I could multiply to -3 and add to 14. You know very quickly that the only ways to deal with 3 or -3 are 1 and 3 or 3 and 1. So that's not going to get us anywhere. So instead we're going to use completing the square. So this will help us get to the answer instead. So I think about my binomial here, and I ask myself, what could I add, well, to both sides of the equation, but particularly, what could I add here to turn this into a perfect square trinomial? So this is what I want to be thinking. I want to be able to add to 14, and then I want to think about whatever that number would be squared would give me this here. So I'm thinking about x plus what and x plus what. And your 14 would have to be 7 and 7. When you take care of your FOIL, you're adding 49, because 7 times 7 is 49. If I add 49 to the left side, I have to add it to the right side to keep it equal. So that means the left side, I could actually call this x plus 7 quantity squared equals 52. Now, I want you to think about this. I want to square root both sides of my equation. That's going to allow me to undo this squaring. And just as an aside, this is what I could say if I had something like x squared equals 25. That what I would want to do is square root, but just remember I'm putting that plus or minus there because the square root of 25 could be positive or negative 5, right? Negative 5 squared or 5 squared, sorry, that's a 5, both give us 25. So that's why I'm dealing with this plus or minus here. So that means I get x plus 7 equals plus or minus the square root of 52. And then just to move the 7 over, I get x equals negative 7 plus or minus the square root of 52. Let's practice that again. Okay, so here I actually, well, we'll see in a second. I think you're going to like this one. The left side is actually a perfect square trinomial because I have 6 and 9, so I know how do I add to 6 and multiply to 9. It's 3 and 3, so x plus 3 times x plus 3 equals 4. Or x plus 3 quantity squared equals 4. And then I need to undo this squaring, so I square root, it's plus or minus, because again, 2 squared is equal to 4, and negative 2 squared is equal to 4. Then I'm going to, after I've square rooted both sides, I'm just left with x plus 3 on the left side, and that equals plus or minus the square root of 4, which I know is 2. So then I'm going to subtract 3 from both sides. I get x equals negative 3 plus or minus 2. You actually know what this is. This means negative 3 plus 2 is equal to negative 1, or negative 3 minus 2 is equal to negative 5. So my two answers on this problem were negative 1 and negative 5. This one is a little bit different because I don't just have an ax squared plus bx over here. I also have this c. So what I do to help myself out is I just add 4 to both sides first, and then I can think about my perfect square trinomial without having anything else to think about. So I have x squared minus 2x equals 7. So I'm going to ask myself again, what could I add to this side, add to this side, so then I end up getting a perfect square trinomial. So I'm asking myself, what could I do to add to negative 2? And half of that would be negative 1, so I'm going to have x minus 1, x minus 1. So that means I am adding, when I'm using FOIL, that I'm adding 1 to this side. If I add 1 to the left side, I have to add 1 to the right side. So I end up getting 8. So then I have x minus 1 quantity squared equals 8. I'm going to square root both sides to get rid of that squared, plus or minus. So this is when this is going to go back to something that you did last year. So I have x minus 1 equals, so the square root of 8. The square root of 8, I want to think about what perfect squares are inside 8, are factors of 8. So I always think of it as the square root of 4 times the square root of 2. I always try to think about what is the greatest perfect square, 1, 4, 9, 16, 25, etc., that are factors of it, so I can simplify my radical. So what's the square root of 4? You know that the square root of 4 is 2, so this is the same thing as 2 root 2. So if that doesn't feel familiar, it will after a few days, but I know that that's somewhere when you were doing all your work with Pythagorean work last year in 7th grade. Okay, so I have plus or minus 2 root 2, and then I'm going to add 1 to both sides, and then I get x equals 1 plus or minus 2 root 2. And this is when you want, some people will ask about if you can put those things together. I just want you to think about it as, we don't know what the square root of 2 is. It's an irrational number. So I can't combine it with something that's a constant. They're different. So this is my answer this time. X equals 1 plus or minus 2 root 2. Let's just continue with this example just for one more minute. So I just want you to think about this so that you're thinking that you have 1 plus or minus, and this is about 2.8 approximately. So you could say this is 1 plus 2.8 is one option, or 1 minus 2.8 is another option. So 1 plus 2.8 would mean 3.8, sorry, and 1 minus 2.8 would be negative 1.8. And what that tells us is that in our original equation, that our x-intercepts of that graph were either 3.8 or negative 1.8. Those are our two x-intercepts. So we wouldn't have been able to get that without completing the square. We could approximate it really nicely using GeoGebra or the graphing calculator, which is awesome. But this right here actually gives us the exact value. So when you hear that exact value, that means you're being asked to find an answer with a radical in it, or a square root. An approximation here is nice that you have here of 3.8 or negative 1.8 also. We're going to find a couple other ways that you could solve these, but completing the square is really helpful. And hopefully once you get the hang of it, it's a piece of cake, but it's just another thing to practice. Okay.